Much of the commercial fertilizer sold to farmers and gardeners in the United States is either extracted from natural gas or mined from the ground. This is an expensive process with lots of byproducts. The owner of NTP Technologies in Chesterfield County is hoping to use just air and water to advance farming into the 21st century.
Basically, the machine has a compressor in it, a plasma core, as well as a power supply. Those three components make up the majority of the machine itself. Right now, if you can see, we have a gallon of water here, several gallons of water here. It just uses air and electricity in order to power the actual system. We then use that air and the plasma, ionizes the air, and then we bubble it through this stone. And if you can see, what we'll do is we'll actually just place it in here, the air bubbler into the water. One button on the machine, turn the machine on, you can see the bubbles start going. And what that's doing is it's ionizing air just from the atmosphere, pushing it through the plasma system, and actually generating nitrates in the water.
John Ireland stopped by Virginia State University's Randolph Farm Research Station to demonstrate his product. He has a background in petrochemicals and the fertilizer industry and a master's degree in biochemical engineering. He says the technology to extract nitrogen products from air is a century old. The challenge has been how to extract it affordably.
So we're going to test the machine. It's just turned off a little while ago. And we use these test strips. They do nitrate and nitrites. The way you actually do it is you just take a strip, and you can see there's no colors on this strip. We're actually then going to dip it into the water for approximately 2 seconds, just to get it wet. And as it comes out, you can see now its color. If you take a look at it against the color chart, you can actually see the difference in terms of nitrates and nitrites. Nitrites being on the bottom, nitrates on the top. It's about 10 to 1, 25 to 225 parts per million nitrites, 250 parts per million nitrates.
What's interesting about the product is that 78% of the atmosphere is nitrogen. And the only way to get that nitrogen to plant has typically been through bacterial processes, nitrification or nitrogen fixation. His technology takes that nitrogen from the air and makes it available to the plant. And if that can work out well and be transformed into a product that can be scalable and usable, that can really be very important to agriculture.
Scott Lohman is Vice President of Research at the Institute for Advanced Learning and Research in Danville, Virginia. His team is testing whether this technology really can deliver the fertilizer elements that plants need. As part of its mission, IALR works with several companies and academic clients to improve processes for controlled environment agriculture operations.
Controlled environment ag allows things to be grown indoors year-round. It's much more like advanced manufacturing. It's a high-tech industry, so robotics play a big role. The food is more local, so you're serving regional markets, and they're able to get fresh food immediately. It cuts way down on transportation costs. Again, it's jobs for the region. The product is fresher, and you know every step of it. When you're in controlled environment ag, you control all of those, and it makes it a very promising technology for the U.S. to not displace corn or soybeans. It'll never do that. But these smaller specialty crops, it's a tremendous business producer.
The NLab prototype shows so much promise that it won the second annual Virginia Foundation for Agriculture Innovation and Rural Sustainability Agricultural and Forestry Innovation Challenge, better known as the Bullpen. Ireland and the NLab competed against 3 other finalists for cash prizes. The goal of the competition is to encourage more innovative ideas to advance agriculture and forestry in Virginia.
Bullpen provided me a venue to actually showcase our technology to the farmers here in Virginia. We were a finalist, which was nice. We got a little bit of money for that. And then as the winner, we got a little bit more, which is nice because it's going to give me the ability to do some additional testing and trials, as well as talk and network with more Virginia farmers and try and get this technology out into the marketplace as quickly as possible.
Since this process extracts nitrates from the atmosphere through water, Ireland says it's ideal for use in greenhouse operations, where irrigation systems are already in use.
Plants like these are in soil. You can actually have others that are actually in water. Either way, they need nutrients applied to them on a regular basis. We're providing a material that has no salt in it, that's good for the environment, and that our job is to make sure it's affordable for the farmer.
Eventually, he foresees scaling up to the point that any crop operation that uses irrigation could benefit. He's interested in finding growers willing to test his machine in real-life conditions and investors willing to support his growing company. Working with the IALR is just the first step.
Working with startups like NPT Technologies is really the most fun things we do, because a lot of times larger companies have a lot of things figured out already, but smaller companies, we really feel like we can help be beneficial to them.
With supply shortages and high petroleum prices, anything that can help farmers and growers stabilize their input costs could be a real plus. Who knows, NPT Technologies could be a key success story for the future, born and tested right here in Virginia. To learn more about the Bullpen Challenge for agricultural entrepreneurs, visit the VA Fairs website and check out NPT Technologies website and the Institute for Advanced Learning and Research online as well. Reporting from Richmond, Virginia, I'm Norm Hyde.